Dear students, good morning. Today, the discussing topics are first, importance of the universal law of gravitation, and second, the related numerical. In earlier class, you studied about how can the moon revolve around the earth. Can you recollect it? The moon revolves around the earth due to centripetal force, which is the force of gravity of the earth. If the force of attraction between the earth and the moon ceases, then the moon will continue to travel in a straight line path, which is tangential to its orbit around the earth. And also you have seen that a stone tied with a thread when it whirled was executed to circular motion. To remain it in its circular path or its orbit, it should be provided the centripetal force forever. Who did provide the centripetal force to that stone? No doubt to say it is that person who whirled the stone. So it can say that centripetal force is associated with an external agent. Here the agent is that person. Now, can you answer the question, how do the Earth, the Moon and other planets stay in their orbits around the Sun? It is due to the centripetal force exerted by the Sun to them. So the agent is the Sun. Hence, it is understood that centripetal force is equivalent to force of gravity here. Next, you are going to study about what are the importance of universal law of gravitation. The universal law of gravitation successfully explains several phenomena which are believed to be unconnected. First one, the force that binds us to the earth. Second one, the motion of the moon around the earth. Third one, the motion of the planets around the sun. And fourth one, the tides due to the moon and the sun. These important points I repeat again. The first one is the force that binds us to the earth. It is due to the gravitational force that we are bound to the earth. If the gravitational force is not there, all the terrestrial bodies would have floated in air. The human life would not have been possible. Second one is the motion of the moon around the earth. The moon is orbiting around the earth, which is due to the gravitational force between the moon and the earth. Third one is the motion of the planets around the sun. All the planets are revolving around the sun due to the gravitational force exerted by the sun to them. And fourth one is the tides are formed in the ocean due to the gravitational force exerted by both sun and moon on the earth. Do you know about the book The Mathematical Principles of Natural Philosophy? This is the book about whom Sir Isaac Newton's groundbreaking work in physics was first published in 1687 in his book, which is named as The Mathematical Principles of Natural Philosophy, which is commonly known as the Principia. In it, he outlined theories about gravity and of motion. Let me discuss on the numerical part. First question is, calculate the force of gravitation between the earth and the sun given that the mass of the earth is equal to 6 into 10 the power of 24 kg and mass of the sun is equal to 2 into 10 the power of 30 kg. The average distance between the two is 1.5 into 10 the power of 11 meter. What is the solution? According to this question, m sun is equal to mass of the sun is equal to 2 into 10 the power of 30 kg. M earth is equal to mass of the earth is equal to 6 into 10 the power of 24 kg, and r is equal to average distance between the earth and the sun, which is equal to 1.5 into 10 the power of 11 meter. By applying universal law of gravitation, F is equal to G m1 m2 divided by r square, which is equal to G m earth m sun divided by r square, where G be the universal gravitational constant, which is equal to 6.67 into 10 the power of minus 11 Newton meter square per kilogram square. Therefore, putting all the values in the above expression, we get F is equal to 6.67 into 10 the power of minus 11 into 6 into 10 the power of 24 into 2 into 10 the power of 30 divided by 1.5 into 10 the power of 11 whole square, which is equal to 3.56 into 10 the power of 22 Newton. Second question is, the mass of earth is 6 into 10 the power of 24 kg, and that of moon is 7.4 into 10 the power of 22 kg. If the distance between the earth and the moon is 3.84 into 10 the power of 5 kilometer, calculate the force exerted by the earth on the moon, given G is equal to 6.7 into 10 the power of 11 Newton meter square per kilogram square. What is its solution? Given that mass of the earth ME is equal to 6 into 10 the power of 24 kg. Mass of the moon MO is equal to 7.4 into 10 the power of 22 kg, and the distance between the moon and the earth r is equal to 3.84 into 10 the power of 5 kilometer, which is equal to 3.84 into 10 the power of 8 meter, since 1 kilometer is equal to 1000 meter. Here we have to find the gravitational force. We know that G is equal to 6.67 into 10 the power of minus 11 Newton meter square per kilogram square. By applying universal law of gravitation, F is equal to G ME/MO divided by r square. On substituting these values all, we get F is equal to 2.01 into 10 the power of 20 Newton. Third question is, what is the magnitude of the gravitational force between the earth and 1 kg object on its surface? Mass of the earth is 6 into 10 the power of 24 kg, and radius of the earth is 6.4 into 10 the power of 6 meter. By applying universal law of gravitation, the gravitational force exerted on an object of mass m is given by F is equal to G capital letter M small letter m divided by r square. This is expression number 1, where mass of the earth capital letter M is equal to 6 into 10 the power of 24 kg. Mass of the object small letter m is equal to 1 kg, and universal gravitational constant capital letter G is equal to 6.67 into 10 the power of minus 11 Newton meter square per kilogram square. Since the object is on the surface of the earth, capital letter R is equal to radius of the earth, which is equal to 6.4 into 10 the power of 6 meter. Therefore, gravitational force F is equal to G, capital letter M, small letter m divided by r square is equal to 6.67 into 10 the power of minus 11 into 6 into 10 the power of 24 into 1 divided by 6.4 into 10 the power of 6 whole square, which is equal to 9.8 Newton. And fourth question is, what happens to the force of gravitation between two objects if A, the distance between them is reduced to half, and B, the mass of one object is doubled? Here we have to solve two things. First one, what should be the gravitational force between these two objects when the distance between them is reduced to half? And second one, what is the gravitational force when the mass of one object is doubled? What is the solution? Here we have to apply universal law of gravitation. According to it, the gravitational force of attraction between any two objects of mass capital letter M and small letter m is proportional to the product of their masses and inversely proportional to the square of distance between them. Let small letter r be the distance between these two objects. We know that F is equal to G capital letter M small letter m divided by r square. A. We have to find the gravitational force when the distance r is reduced to half. By applying the condition, that is r becomes to be r by 2, the above expression becomes as f dash is equal to g capital letter M small letter m divided by r by 2 whole square. That will be equal to 4 into g capital letter M small letter m divided by r square, or f dash is equal to 4m. Here, if the distance is reduced to half, then the gravitational force becomes 4 times larger than the previous value. And B, what should be the gravitational force if mass of one object is doubled? By applying universal law of gravitation, force exerted on an object of mass small letter m by earth is given by F is equal to G capital letter M small letter m divided by r square. This is the expression 1. When mass of the object, say, m is doubled, then the above expression becomes as f dash is equal to G capital letter M into 2 small letter m divided by r square. Here m becomes to be 2m, which will be equal to 2f. So as the mass of any one object is doubled, the force is also doubled. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.